Okay, transformations. So we learned this giant equation, f of x equals a f k x minus d plus c. So we learned this huge equation to help us understand transformations happening to graphs. So we learned that A was a vertical stretch or compression, and also a reflection in the x-axis. That's what A does. We learned that K is a horizontal stretch or compression, and also a reflection in the y-axis if K is negative and if A is negative here. We learned that D is a horizontal translation, so it's going to shift our graph left or right. And we learned that C can shift our graph up or down. Okay, so now we just have to apply those things. So let's say we're working with a base function y equals x squared, so a parabola. And we're going to transform it into f of x equals negative 3 x plus 2 squared minus 1. So first we want to state what's happening with this graph. So this negative sign here is telling us we have a reflection in the x-axis, because that's our a value and it's negative. This here is saying we have a vertical stretch by a factor of 3. This right here is going to shift our graph left 2, and this one's going to shift it down 1. So now I know all of that information. So if we were going to graph this graph, I always like to graph the original function, the parent function or the base function, which is this, y equals x squared. And then I'll graph the transformed function. So I know it's getting reflected, so it's going to open down like that. I know it's getting vertically stretched, so therefore it's going to be skinnier. And then I also know it's going left 2 and down 1. So it's going left 2 and down 1. It's going to be here, and then it's going to be going down in this direction. So that's my transformed graph. Perfect. Let's try another one. Okay, I'm going to start with a base function of root x this time. And I'm going to apply some transformations. So let's say I gave you one that was root negative 2 x plus 1 minus 5. Okay, so first let's state our transformations. So this negative sign here and this 2, they're both our k values since they're inside of the function. So the negative is going to cause a reflection in the y-axis, and the 2 is going to cause a horizontal compression by a factor of 1/2. This positive 1 here is going to shift our graph left 1, and this minus 5 is going to shift it down 5. Okay. So if I sketch my original first, I know my original graph starts at 0, 0 and goes off in this direction. That's my original root x graph. If I want to apply the transformations and sketch it, okay, so first dealing with the reflection in the y-axis, that's going to cause my graph to go that direction. Second, a horizontal compression by 1/2. It's going to cause my graph to be smushed horizontally. So it's almost the same as a vertical stretch. What? Okay, sorry. Okay, so it's going to actually cause my graph to kind of open up farther. Okay. Sorry. Okay, and then left 1 and down 5. So let's apply all of that stuff. So left 1, down 5, 1, 2, 3, 4, 5. So it's starting here, and it's going to go something like that. Okay, and let's try a reciprocal one, because those ones are tricky. So our original graph is a 1 over x, And we're gonna put some transformations on it. So let's stick a 2 on top, make it x plus 3 minus 1. Okay, so here's our reciprocal function, which already looks crazy. So this guy on top is actually our a value, and it's going to get vertically stretched by 2. This one down here is our d value, and it's going to go left 3. And this one here is our c value, so it's going to go down 1. Okay, so the reciprocal one's a little tricky to sketch, but our original reciprocal function looks like this, kind of. And what's important to note for the reciprocal ones is the asymptotes. So currently the asymptotes are along the x and y axis. So right now, this graph has asymptotes at x equals 0 and y equals 0. That's where they are right now. Okay, but we're going to transform our graph slightly. So we're moving it left 3 and down 1. So 1, 2, 3, 1. So that's actually going to affect our asymptotes. So it was at 0, now our asymptote is going to be at negative 3. And we did have an asymptote at 0, and now we're going to have an asymptote at negative 1. So this graph has asymptotes at x equals negative 3 and y equals negative 1. And then when we sketch our graph, we know it's got a vertical stretch of 2, but I mean that matters, you know, a little bit less. Some things you could do to try to get a more accurate graph would be maybe the y-intercept x is always 0. By subbing 0 in for x, you'd get 2 over 3 minus 1, which is 2 over 3 minus 3 over 3, which equals negative 1/3. So our y-intercept is going to be down here somewhere, which, I mean, that doesn't help too much. We could try to figure out our x-intercept too if we want by subbing y equals 0 and just rearranging the equation. But I'm just going to go ahead and graph it. It's going to look something like this, and the other part is going to be down here. As long as they don't cross these asymptotes and you have this kind of shape, you're good.